Hi guys, and welcome to Learn Extra Session 7. In this section we're going to look at drawing graphs. But before you can sketch any graphs, you first need to know how to plot values. And before we plot values, we need to identify our axes. The x-axis is also known as the horizontal axis. And the y-axis, we also call that the vertical axis. So if I draw a set of axes for you, the x-axis is the horizontal one where you plot all your independent variables. Remember, a variable is something that changes values all the time. And then on the y-axis, we plot all the dependent variables. So the dependent variables, they depend on the x value. So we plot all our dependent y values on the y-axis and the independent values on the x-axis. And all of your values on the y-axis will be affected by the values on your x-axis. Another important point is to always use a suitable scale. Now guys, this is very important because if you don't pay attention to your scale, you could end up drawing a graph that's just far too big and won't fit on your page. Or alternatively, you could end up with a tiny graph that we won't be able to read. So make sure you use a proper scale. And in order to do that, you have to identify your highest and your lowest values, and then that will tell you what scale you should use. Very, very important. Always label all your axes, and you have to provide a title for your graph. We need to know what's going on in that graph. What is the name of that graph? Okay, so you have to provide a title for the graph. And then another thing to remember is that your discrete values, these are values that have specific numbers. So for example, the number of people in a class. Those discrete values you cannot join on a graph because it doesn't make sense, for example, to have 20.5 people. This will make more sense as we look at the examples, but just remember, with your discrete values, we plot those as dots and we do not join the dots. Your continuous values are the ones where you are allowed to join the dots and get a smooth curve. So with that in mind, let's look at example 1. We are told that in a school there are 100 learners in grade 8, 120 learners in grade 9, 160 learners in grade 10, 140 in grade 11, and 120 learners in grade 12. They then want you to draw a neat graph showing the grades on the x-axis and the number of learners on the y-axis. So what they've immediately told you is that the grades, which has to be plotted on the x-axis, would be your independent variable, and the number of learners, which we plot on the y-axis, that would be our dependent variable. So the number of learners depends on what grade they are in. All right, the first thing you should do is to always label your axes. So in this case, they made life easy for you and they told you plot the grades on the x-axis. So we label the x-axis as grades. And the number of learners is on your y-axis. So we call the y-axis the number of learners. And then very, very important, you need to provide a title for your graph. And because we are looking at the number of learners per grade, we can simply call our graph that. So this will tell the person that's looking at your graph what is being sketched. So our title will be the number of learners per grade. Okay, so now we have our labels, we have our axes drawn. The important thing here now is to work out our scale. I've already worked out the scale, but how you would do it is you look at the question, you identify your lowest value, which in this case is 100, and you identify your highest value, which in this case is 160. And you then decide, well, to go between 100 and 160, what type of scale would I need to use? So you need to use a scale that's going to be adequate enough to show the points properly. You don't want to use a scale that's too big, because obviously that would go off the page. You also, I'm starting my axis at 0, so that will give it a clearer picture of what's going on. Okay, so you don't want to start your axis at, say, 40 or 50 or so on. You want to start it at 0 and then build up from there to build a clear picture of what's going on. All right, so what I've decided is to use a scale of 40 on the y-axis, and we can then plot the points that we are given. We are told that in grade 8, we have 100 learners. So to plot the point, all you do is from the grade 8, you're going to go up, and you're going to look at the point of intersection of 8 and 100 on the y-axis. Now, in order to find 100, you've got to be careful. We don't want a point that's too close to 120. We don't want a point that's too far away from 80. So how you decide, remember, you know that between 80 and 120, there are 40 units. So halfway there would be 20 units. So 80 plus 20 sort of takes me midway. So 100 is sort of midway between 80 and 120. So at that point where they intersect, we will put a little dot to represent that in grade 8, we have 100 learners. So similarly, we'll go through all the points and we'll put little dots where the value on the x-axis and the value on the y-axis intersects. So if we go to grade 9 now, there we have 120 learners. So doing exactly the same thing, you go across on the x and the y-axis, and where they meet is where your dot will be. So in grade 9, we depict 120 learners. And then in grade 10, we've got 160 learners. So this one's a little bit further up. So try and be obviously as accurate as possible when you're doing this. So it makes, if you have a ruler or that in school, then use that to plot your points accurately. In grade 10, we've got 160 learners and 140 learners in grade 11. So 140 now, it's one of those that's midway between 120 and 160. So it's sort of midway between there, and we are going to plot a point that intersects, or it's where the two intersect, where the value on the x and the y-axis intersect. And then finally in grade 12, we are told that we have 120 students. So that's going to be in line with the learners that are in grade 9. All right, so that's basically how you plot points. You would sort of find your value on the grade axis or your x-axis, go across onto your y-axis, and where the two meet is where you will plot your point. Okay, that's a very, very basic example, and basically you're just going to need a little bit of practice in order to plot points. It really is the basics of sketching a graph, and once you get it, you'll be able to plot any graph. Now guys, with this type of graph, we cannot join the dots. Now the reason we cannot join the dots is because these are discrete variables. Discrete variables take on specific values. So for example, if you look at the grade 8 learners, there are 100 learners. It doesn't make sense to have 100.5 learners, which is what you would imply if you were to join the dots together. So because these are discrete variables, you are not allowed to join the dots. Now guys, sometimes you can be given a formula and then asked to sketch the graph from the formula. In this type of example, you will then have to choose for yourself what points you should be plotting. But the more points you use, the more accurate your graph will be. So bearing that in mind, let's look at example 2. We are told that the formula to convert from degrees Celsius, that's what temperature in South Africa is measured in, to degrees Fahrenheit. They tell you the formula is F, which is degrees Fahrenheit, is equal to 9/5 times C, which is your degrees Celsius, plus 32. The first part of the question wants us to use the formula to complete the table below. And in the table, they've given us a whole lot of values that we can use for degrees Celsius, and we obviously have to find out what the corresponding degrees Fahrenheit value will be. So all we have to do, if I would like to know what 0 degrees Celsius translates to in degrees Fahrenheit, I basically just have to substitute the 0 degrees in place of the C. So this would become 9 over 5 times 0 plus 32. So in place of degrees Celsius, I put in 0 degrees Celsius. If we work this out, this will give us an answer of 32. So in my table where I have a 0 degree, I can now put in 32 degrees Fahrenheit as the corresponding temperature in degrees Fahrenheit. Similarly, we can do the same thing for 5 degrees Celsius. All I have to do is put the 5 in place of the C. So it becomes 9 over 5 times 5 plus 32. The 5's cancel and I get 9 plus 32, which is 41 degrees Fahrenheit. So in my table, beneath the 5 degrees, I would put down 41 degrees. Similarly, we can do that with the 10 degrees. So put in the 10 in place of the C in your formula. If you do that, you will get an answer of 50 degrees Fahrenheit. I'm not going to do all of the substitution for you. You can do that by yourself. And when you are done, make sure that you get the following degrees to complete the table. For 15 degrees Celsius, you will get a corresponding 59 degrees Fahrenheit. 20 degrees Celsius would give you 68 degrees Fahrenheit. 25 would give you 77, and 30 would give you 86, and 35 degrees will give you 95 degrees Fahrenheit. So we've already answered the first part of the question. We have completed the table by making use of the formula. They then ask us to plot the points from the table on a graph with the degrees Celsius on the x-axis. So when you read your question, make sure you understand what they're saying. If they say degrees Celsius is going on the x-axis, what they've said to you is that degrees Celsius is the independent variable, and this will force changes in the dependent variable, which is your degrees Fahrenheit. So in other words, any change in degrees Celsius would mean a change in degrees Fahrenheit, which we will plot on the y-axis, and we call that our dependent variable because it depends on the temperature in degrees Celsius. They then say clearly label the graph, which you should always do. Make sure that your graph is clearly labeled. And in this case, it's very nice because we've already got the scale drawn for us. We can see that the scale used on the x-axis is 5, and then the scale on the y-axis is 20. Let's label the axes. We know that degrees Celsius goes on the x-axis. So on my x-axis, I say degrees Celsius. And then on the y-axis, we have degrees Fahrenheit, or you can write it out. And for the label, what are we doing? Well, all we're doing is we're converting from degrees Celsius to degrees Fahrenheit. So that's a suitable title. We can say converting from degrees Celsius to degrees Fahrenheit. All right, and now that we've got our table drawn from above, it's very easy to plot the points because they have given us the x values and we have worked out the y values. So it's simply a matter of plotting these corresponding points onto our x-axis. So let's do that. Remember at 0 we had 32, so all we do is at 0 degrees Celsius, we know that's the same as 32. Now that's going to be somewhere between 20 and 40. If there are 20 units between 20 and 40, halfway would be 10 units. So up to that point is about 30. So 32 would be slightly above that point. Okay, so at 0 degrees, we make a little dot to show the 32 degrees Fahrenheit at 0 degrees Celsius. Then at 5, we had a value of 41. So 40 is at that point, so 41 must be slightly above that. And we make a little dot where we think that is. at 10 degrees Celsius, that corresponded to 50 degrees Fahrenheit. So now here, 50 is somewhere between 40 and 60. We know that to get from 40 to 60 is 20 units. So halfway would be 10 units, and at that point would be 50. So at 10 degrees Celsius, we plot 50 degrees Fahrenheit. Now we go to 15. 15 was the same as 59, which is slightly below 60 degrees. So again, just below 60 on the y-axis. We put our little dot. So we go up on from 15 on the x-axis, across 59 on the y-axis, and where they meet, we put our little dot. And then at 20 degrees, that was the same as 68. Now that's somewhere between 60 and 80. So using the same pattern, halfway would be 70. So if I'm looking for 68, it's slightly below halfway between 60 and 80. All right, and then at 25 degrees, we have to plot 77. This is slightly further away because 70, remember, is halfway. So this is going to be closer to the 80. And I'm going to go across where they meet, put a little dot at 25. At 30 degrees, we had to plot 86 Fahrenheit. So that's somewhere between 80 and 100. Using the same concept, between 80 and 100 would be 90 degrees. So we know it's definitely going to be below that, slightly below. So we've got 86, we go across. At 30, we're going to plot 86. And then finally, at 35 degrees, we have to plot 95, which is quite close to 100. So we go up 35 on the x-axis, very close to 100, just above 90. So there we go. So we've got all of our dots here that we have plotted to show the values from the table. Okay, so you would be able to, if you draw this accurately, you would be able to go to your graph and read off the points. So quite accurately, you could say, okay, well, at 0 degrees, I can read off 32. At 20 degrees, I can read off a value of 68. So it's important to plot this correctly. And you will be given these sheets in your exams. They will give you these axes in your exam paper. They then ask you to join the dots on your graph and explain why you are allowed to join the dots. All right, so let's join the dots first, and then we can say why we are allowed to join the dots. Okay, so hopefully they all form a nice straight line. There we go. We've joined all of our dots. Now they say, why can you join the dots? Now let's go back to when we started the session, and I said to you that discrete variables, those are specific values like the number of people, those we cannot join the dots, but we can join the dots on continuous data. Continuous data being things like temperature. So it is very possible to get, for example, today, for it to be 5.5 degrees. That's very, very possible. Therefore, a straight line gives us in-between values that are all allowed. Okay, so when we join the dots and get this straight line, it means we are basically taking any in-between value, and that means that we are dealing with continuous data, and that is the reason we are in fact allowed to join the dots on this graph. So that is a typical example where you can be given a formula and then asked to sketch a graph. Now some hints and tips when you are asked to sketch a graph using a formula. Firstly, when you plot from a formula, always make sure you understand all of the variables being used. So understand all variables. So you need to know what the x and the y values represent. Okay, then also very important is to identify the independent and the dependent variable. That will also then tell you what you should be plotting on the x-axis and what you should be plotting on the y-axis. So it's important to identify which variable depends on which. And then finally, always use an appropriate scale. So use the correct scale. And then as always with every graph, make sure you label your axes and give your graph a title. Next, we're going to move on to linear graphs. Now, graphs of a linear relationship form a straight line. The standard form for any straight line equation is y is equal to mx plus c, and this is a very common equation that you will come across time and time again. Let's just identify what each of these letters stand for. M is the gradient. The gradient tells you what the slope of the graph is like. So in other words, how steep the graph is. And C is your y-intercept, which tells us where the straight line is going to cut the y-axis. So this gives you the cut on the y-axis, and that value you will find by letting x equal to 0, but we will go into greater detail in a little while. Okay, so this is the standard form. Y is equal to mx plus c. Your gradient can also be positive or negative. When you are dealing with a positive gradient, you will have a graph that slopes towards the positive numbers. That's how I like to remember it, because all our positive numbers are on the right-hand side of the number line. Or a negative gradient means your graph slopes towards the negative numbers, since on your number line, all the negative numbers are on the left-hand side. There are different methods that we can use in order to sketch a straight line. The two methods that I'm going to be looking at are the table method. These are the most common methods of sketching straight lines. And we also do something called the dual intercept method. And what we're going to do, guys, is we're going to explore both of these methods in greater detail by looking at example 3. Example 3, the first part says, sketch the graph y is equal to 2 times x using the table method. Before we do anything, let's just identify our gradients and our intercepts here. This graph, y is equal to 2x, I can put a plus naught in there because it doesn't affect the value of anything. And this is now in standard form. The value of 2 here is my gradient, that's the m value. The naught is the y-intercept, which tells me where, or the c value, that tells me where this graph is going to cut the y-axis. And what we see here is that the gradient is positive, which means I'm going to have a graph that slopes in the positive direction, so it slopes towards your positive numbers. Okay, so we've identified the shape just by looking at the given equation. Now what you do with the table method, you have to use values, and now this is really at your own discretion. It's sort of like substituting into a formula and then sketching a graph, which we did before. What you have to do is decide what values you would like to put in that table. So there's no set rule. But what I like to do is always use naught, because naught is an intercept, which tells us where the graph's going to cut an axis. So I always like to use naught for the value of x, which is these are always your independent variables. Remember from before we said that. The x values are your independent variables. And for your independent numbers, you can use anything you like to the left and to the right of naught. So what I'm going to do is I'm going to take 1 and 2, positive 1 and 2 to the right of 0, and then minus 1 and minus 2 on the left of 0. Okay? And then in order to fill this table in, we need to find the values of y. We want to find what the values are that depend on these x values that we have chosen. So we have put these in, remember. You can use anything you like. The more points you use, obviously, the more accurate your graph will be. In order to determine the y values, we are given the formula y is equal to 2 times x. And remember, x is the placeholder for all these x values. So if I would like to find out what the y value is, all I do is substitute my x values. So my first x value I've chosen is minus 2. So if I would like to know what the corresponding y value is, all I do is I put minus 2 in place of x in this formula, and I get 2 times minus 2, which gives me minus 4. So what this tells me is that on my axis, I am going to have a corresponding value of minus 4 when x is minus 2. So that is a point that I will plot. Now just while we're on that as well, we have something called coordinates or ordered pairs. That is the way that we use brackets to write the set of x and y values. So we use our brackets. The first value always represents your x value, and the second value always represents your y value. So the point minus 2 minus 4, I can represent as, in brackets, the coordinate minus 2 minus 4, which means the x value is minus 2, the y value is minus 4. Okay, let's find the y value when x has a value of minus 1. So all I'm going to do is put minus 1 in place of x in the formula. 2 times minus 1 will give me minus 2. Therefore, when x is minus 1, my y value is minus 2. And then for the value of 0, which is the y-intercept, all I do, again, in place of the x value, put in a 0. 2 times 0 is 0. So when x is 0, y is 0. So that point, 0, 0. Also a very important point. It is also called the origin when you deal with your Cartesian plane. Your Cartesian plane, remember, is this fella down here. It's where we draw our x and our y axes. The center point here, 0, 0, that's also called the origin. So this 0, 0 tells us that this straight line is going through the origin. To find what the y value is when x is 1, again, we put it into the formula. You do that, you get a value of 2. And by putting the 2 into the same formula, you will get a value of 4. So now you've got a whole lot of ordered pairs, a whole lot of points that you can plot on your axis in order to sketch the graph. Okay, and remember this graph, y is equal to 2x, where the gradient is 0. We are sketching using the table method. The table method is the method where you decide what to put into the table. Using that formula, you will get your values. All right, so remember they asked us to sketch the graph. So we've got a set of axes here. This is basically a representation of your number line. We've got 0 in the center, all our positive values on the right of 0, and then all the negative values to the left of 0. And then this is exactly the same thing just now vertically. So this is your x-axis on this side, on the horizontal side, and your y-axis on the vertical side. So from our table, all we're going to do is plot these points that we have just worked out. When x was minus 2, we know that y had a value of minus 4. So all we are going to do, like before, you have to know how to plot your points. When x is minus 2, we go down. We find the point where it meets minus 4 from the y side, from the y-axis, and that's where we do our little dot. So that represents the point x is minus 2 and y is minus 4. Then we know when x was minus 1, the y value was minus 2, so we go down from minus 1 on the x-axis, across from minus 2 on the y-axis, and then we put a little dot where they meet. And then another point was 0, 0, which is the center, the origin. Another value was x is 1 and y is 2, so where they meet, we put a dot. And when x is 2, y was 4. And as you can see, once you've drawn that, you're now in a position to sketch this graph. And these straight lines are all graphs of continuous data, so obviously you are expected and allowed to join those dots. So let's do that. Okay, and that's the graph. Remember to label your graph. That's the graph y is equal to 2x. And then also very important, because this graph continues forever and ever. Remember, we just chose these specific values, but this is a straight line. It can go on infinitely. What I do is I put little arrows at the end of my line to show that it continues infinitely. And in fact, to be more correct, your axes should also have arrows at the end to show that they continue infinitely, because remember, those are number lines, they carry on forever. So always when you're drawing your straight lines, remember to put the little arrows at the end to show that they will continue forever. Now, in the B part, they say sketch the graph y is equal to minus 4x plus 2, but here they say use the dual intercept method. Remember at the beginning of the section I told you we were going to look at two different methods of sketching. We've just done the table method in the A part of this question. Now we're going to use the dual intercept method, which is another way to draw a straight line. Okay, so we have y is equal to minus 4x plus 2. Let's identify the specific parts in the standard form of our straight line. The value in front of the x, that's your gradient. Here we have the gradient has a value of minus 4. So the 4 tells us how steep the graph is. The minus tells us that the graph will slope, remember? It will slope to the left, towards all the negative numbers. Okay, so the minus 4 tells us the direction of the graph and the steepness of the graph. The 2 is the c value, which is your y-intercept. So that tells us where this graph is going to cut the y-axis. Now the reason this is called the dual intercept method, an intercept, remember, is a value that cuts somewhere on the x and the y axis. So the dual intercept method means that you've got to find both the x-intercept and the y-intercepts. Okay, so when we say dual intercept, we mean we are looking for the x and the y-intercept. Okay, so let's start that method on the next page. Right, so you have y is equal to minus 4x plus 2, and we're going to now do this in a new method called the dual intercept method. So how we do that, firstly, we need to find the x-intercept, and in order to do that, we have to let y equal to 0. Now I'll show you on the axis why that makes sense. The x-intercept, remember, is where this the straight line is going to cut the x-axis. So if you look along your x-axis, at any point, the corresponding y values, when you're on the x-axis, the corresponding y value is always 0. So for example, if I look at 4 on the x-axis, my corresponding y value is 0. So when I'm finding the x-intercept, I am finding out when y is 0, what will the corresponding x value be? That is what we are looking for. All right? So let's do that. So we let y be 0. So this equation is going to become minus 4x plus 2 is equal to 0. All I've done there is replace the y value with the value of 0. And now we have to solve for x. So all I'm going to do is take the 2 over to the right hand side, so it becomes minus 2. Then divide both sides by the minus 4, because remember we're just looking for the x value, so we need to isolate the x by dividing both sides by minus 4. On the left hand side, minus 4 divided by minus 4 is just 1. And then on the right hand side, minus 2 divided by minus 4 will just give us a half. Okay, so we're halfway there. We have the x-intercept. Remember, we said let the y value be 0. So when I write this as a coordinate, I already know the y value has a value of 0. And the x-intercept, or the x value here, has a value of a half. Okay, so half the work is done. Let's move on to the second part, which is to find the y-intercept. So this, remember, is where it cuts the y-axis. If you are awake and you were listening, you would already know that the y-intercept is 2, because I have shown you previously from y is equal to mx plus c that c stands for the y-intercept. So we can see it immediately, but let's go through the process of getting there. To find the y-intercept, remember it's any value along the y-axis. So it's the point where x has a value of 0. So all I do is I take y is equal to minus 4x plus 2, and in place of x, I put a value of 0. So that means the first part of this is going to disappear, because anything times 0 is just 0, and my answer is going to be 2. So therefore, you'll see if your equation is always in standard form, y is equal to mx plus c, you can basically identify the y-intercept straight away without doing any of this work, which means all you would have to do is just find the x-intercept and then you're ready to draw your graph. So it really is a nice, quick, easy way to draw a straight line. Our point here was x is 0 and y is 2. Now that we've got these two coordinates, all that's left for us to do is to go to our axis. Again, remember to have arrows at the end of your axes. We go to the axis and we're going to plot. Remember the first one, your x-intercept, x was 1/2 and y was 0. So on my axis, I look for the point 0, which is somewhere halfway between I look for the point 1/2, which is somewhere halfway between 0 and 1. So we put a little dot there. And then we know that the y value, the y-intercept, when x was 0, y was 2. So all I do then is I go up to 2 on the y-axis and put a dot there. When I join these two dots, so all we're going to do is put a straight line through those 2 points. We will see that we get the following graph. So all I've done is I've joined it from the x-intercept of 1/2 to the y-intercept of 2. Just extend our line a little bit. Remember, these are straight lines, so they do go on continually or forever. So what we do need to do is at the end of these lines put our little arrows to show that the line continues forever. And we have to label the graph. What did we draw? We in fact drew y is equal to minus 4x plus 2. And now if you go back to what we said right at the beginning of this part of the question, the B part, the gradient is negative, therefore we have a graph that's sloping towards the left. And as you can see, our graph does slope to the left. The y-intercept is 2, which we could identify immediately. We have the line cutting the y-axis at 2. And that's how we would draw that line using the dual intercept method. So guys, we've just gone over the two different ways that you can sketch a straight line. That's either by using the table method or by using the dual intercept method. You can choose whichever one you feel more comfortable with. Now in example 4, we are going to look at an application of drawing straight lines. We are told that Alice wants to hire a hall for her 16th birthday party. She then gets quotes from the community hall that will tell her how much she has to pay. They tell her there's a basic fee of 500 Rand to use the hall. So before any guests have arrived, she's got to pay 500 Rand to use the hall. And then she has to pay 20 Rand per person that obviously is going to come to her birthday party. Now the first part of the question, you will often find that if you need to use a table, this question will be broken up for you. So the first part says, complete the table to illustrate the costs that she's going to pay. Remember, she has to pay 500 Rand to use the hall before anyone's arrived. So she pays 500 Rand, that's a standard fee. All right, so when the number of guests, which they give you as 0, 10, 20, 50, those are all the different values. They want to know what will the total cost be when the number of guests are those specific numbers. So when we have 0 people attending her birthday party, so no one arrives to the birthday party, she still has to pay 500 Rand because that's the standard price for using the hall. Okay, if there were 10 guests, how much would she then have to pay? Now, in order to determine this, remember, keep in mind she has to always pay the 500 Rand regardless of how many people are coming. So, if I would like to work out the total cost, I need to add the standard fee of 500 to the 20 Rand times the number of people. So remember, she pays 20 Rand for every guest. So if there are 10 guests, she's going to pay 200 Rand because 20 times 10 is 200 Rand. So since she would pay that 200 Rand plus the standard 500 Rand, the standard fee, she would then have to pay 500 plus 200, which is 700 Rand. So when 10 guests arrive to her birthday party, she would have to pay 700 Rand to use the hall. Okay, if we would like to know how much she's going to pay when 20 people arrive, same thing. to work out the total cost, we need to add the 500 Rand to the cost per guest. She pays 20 Rand per guest, so 20 times 20, and we get 500 plus 20 times 20 is 400, so that would give me 500 plus 400, which is 900. So when 20 guests attend her birthday party, she will pay 900 Rand to use the hall. Finally, if there are 50 guests, we do exactly the same thing. 500 plus 20 times 50. So that will give me 500 plus 20 times 50 is 1,000. So that will give me 1,500 Rand. So Alice would pay 1,500 Rand for this hall if she's going to get 50 guests attending. Okay guys, so all we've done to work out the total cost is we've taken into account the standard fee that she has to pay, and we've now added that to the number of guests she's expecting, and we times that by 20, and that gave us the total amount that she will pay depending on the number of guests. Now what you will see is that as the number of guests increase from 0 to 10, 10 to 20, 20 to 50, her total cost obviously increased as well. So therefore the cost was dependent on the number of guests. So before we go any further, we can straight away say, well, the number of guests must be independent because you can't tell how many guests are coming. Okay, there's no set way to figure that out. But the total cost will always depend on the number of guests that attend her birthday party. So therefore, straight away, before we even try to do the second part, which is sketch the graph, we can identify the independent and the dependent variable, which will help us with the next part. So the next part says sketch the graph using the data from the completed table. All right, before you do anything, because you will get points for this, go and label your axes. That's the first thing you should do. The x-axis, this will be, we can call it number of people. Okay, because remember we've just identified already the number of guests would be our independent variable. It doesn't depend on anything. So number of guests on the x-axis, and the dependent variable, the total cost depended on your number of guests, so the total cost will be on the y-axis. The label for this graph, because once again you will get marks for writing a correct label and correctly labeling your axes, we can say cost of using the community hall. Cost of community hall. Okay, remember, in order to sketch any graph, we have to first plot the points. We have a nice table here that we can use to help us to plot the points. Okay, we know that when there was 0 guests, she still had to pay a set fee of 500 Rand, so therefore this graph is going to start at 500. Alright, so we plot the first point when x is 0, y is 500. Then when she had 10 guests arriving, she had to pay 700 Rand. Now, if we just look at the scale, on the x-axis, we've got a scale of 10 being used, and on the y-axis, a scale of 250. So from, for example, 250 to 500, there's a gap of 250. So midway would be 125. So you can sort of figure out how to plot your points from there. So if I had to put a halfway dot between 500 and 750, this would be roughly 625 rands. Okay, so for 10 guests, she was paying 700 Rand. The little dot I've put in there on the side, on the axis, that represents about 625. So 700 would be above that definitely, but obviously a little bit below 750. So I will say it's somewhere there. All right. At 20 guests, she was paying 900 Rand, so that's just going to be slightly below 1,000 Rand. And at 50 guests, if she gets 50 people coming to her birthday party, she had to pay 1,500, and it just so happens that's the last part of this set axes. They will give you this, your graph paper, in your exam, so you can draw a nice accurate graph. Okay? They asked us to plot that, and it is cost. Cost is money, so therefore it is a continuous thing, because you do get something like 100 Rand and 20 cents and so on. So therefore we can actually join these dots up. So all we're going to do is go from 500 all the way up there to 1,500. All right, and that will be the graph that they asked us to sketch, showing the information from the table. Okay, now the last part says, C, is this an increasing or decreasing function? We haven't touched on an increasing or decreasing function yet. Now this really, when we work with standard form straight lines, y is equal to mx plus c, when your gradient m is positive, so this is just really a side, it's not really part of this question, but it's just in general, you need to know this. When your gradient is positive, remember a line that slopes to the right-hand side, you have an increasing function. So in other words, as your value of x increases, the value of y increases. If m, your gradient, is negative, so you have a graph that's sloping to the left, then you have a decreasing function, which means as the value of x increases, the value of y decreases. So let's go to the graph we've got here. Is it increasing or decreasing? Sloping to the left, we can see that as the number of guests, as the x value increases, the y value also increases. Therefore, this would be an increasing function. And the reason for that is exactly what I just said to you. Your cost increases as the number of guests increase as well. All right, guys, so that's the last example on straight lines and sketching of straight line graphs. What you need to do is really just practice this to get used to this type of graph. The next type of graph we are going to look at is a curved graph. Specifically, we are going to look at hyperbole. Now, a hyperbola is a graph that describes an inversely proportional relationship between two variables. What do we mean by inversely proportional? We have done this before in a previous section, but just to remind you, an inversely proportional relationship is where one variable increases or one quantity increases as the other decreases. A typical example would be speed versus time, because if you think about it, as your speed increases, the time taken to complete the same journey will decrease. So that's a typical example of an inversely proportional relationship. Your graph that you will look at will always be a curve. Specifically, we are going to look at curves that look like that. So our graphs are always going to be curves, and what it means is that as the value on the x-axis increases, the value on the y-axis decreases. Standard form for this equation is y is equal to k over x, where k is some constant number. So that's some sort of constant, like anything you can think of, 5, 10, 15, whatever. And what we are basically saying here is that as this value increases, it makes the fraction smaller, which means the value of y would decrease. So in other words, x times y equal to some constant. That's another way that you can look at it. This type of graph will never pass through the origin, as I showed you there. It's not possible for the x value to ever take on a value of 0, so you will never have an inversely proportional graph passing through the origin. The first example we are going to look at is a typical inversely proportional example. Here we are told in example 5, the prize money for a lottery is 1.6 million rand. If there is more than one winner, the winners will have to share the prize money equally. And in practice, this is really what happens. As the number of winners increase, everyone's share will, they all get a small little share of that amount, so everyone's share decreases as the number of winners increase. The first part of this question wants us to complete the table and to show what each winner will get as a share of 1.6 million rand. So they've set up the table for us, but they haven't filled in any figures. So let's take the number of winners as being, we can choose really any values we want. I'm going to use 1, 2, 4, 5, 8, and 10. As I said, because nothing's filled in, you have your own choice here. So I've chosen 1 winner, 2 winners, all the way up to 10 winners, and we want to know what share of money they are getting in 1,000s. Now this is often the case. We cannot represent 1.6 million all the time. It becomes quite long, quite tedious, very easy to make a mistake. So what we do is we can represent 1.6 million in thousands as 1,600. This is in thousands. And what the in thousands bit means is that if you take the 1,600 times that by 1,000, you will get to 1.6 million. So we haven't actually changed anything. We've just sort of scaled it down to make it easier to work with. All right, in order to complete the table, we have to take into account the fact that they say the winners will share the prize money equally. All right, the first column is very easy to fill in. If there's just one winner, they're going to get all the money. So they're going to get 1,600 in thousands, so they're going to get the entire 1.6 million. If there's 2 winners, remember they're sharing this amount equally. So all I would do is sharing it between 2 people. So I'd have to times by 1 over 2, or divide by 2 in other words, and that would give me an answer of 800. So if there's 2 winners, they each get 800,000. That makes sense. If there are 4 winners, same thing. We take the 1,600. We're sharing it equally between 4 people. So that means each one will get a quarter of the share. So a quarter times 1,600 would give us 400,000. And obviously, if you times it, you always will get back to the original amount. 4 times 400,000 will get me to 1.6 million. 5 winners, we do exactly the same thing. Take the 1,600 times by a fifth. You get the idea. So for the rest of them, I'm just going to fill it in. If we have 5 winners, they each get 320,000. 8 winners will each get 200,000. And 10 winners will each get 160,000. So the important thing to note here is that as the number of winners increase, the share of money will decrease. So that's a typical inversely proportional relationship. As the number of winners, which is our independent variable, so straight away we can say what we're going to plot on the x-axis when we have to draw the graph. As that increases, the share of the money, which depends on the number of winners, that's our y value, our independent value, that will decrease as x increases. So in order to draw a graph to illustrate this situation, once again, as I said to you, easy marks, label your axes. We've got a scale that's already given for us here, 2 on the x-axis to represent the number of winners. So there's a space of 2 between each number. And then on the y-axis, it's going up in 200s. So our x-axis, we've just identified in the table. We're going to say that's the number of winners. So we label the axis. And on the y-axis, we have to label the share of the winners. So here we can say share of money or whatever the case is. But very important is to say that this is in thousands. Okay, so it's in 1,000 rand. So in other words, if you would like to get to the real value, you are saying to the person, take this value, or to the examiner, you're saying, take this value that's given and times it by 1,000 to get to the actual amount. Okay, this graph, we can call it each winner's share of money, or of 1.6 million, or whatever you want to say. So I'm going to say each winner's share of money. All right, or share of 1.6 million. Okay, in order to draw the graph, we have to plot the points that we have been given. Okay, when we had one winner, they get the entire thing. So at the independent variable of 1, which is halfway between 0 and 2, I'm going to go up onto the x-axis, onto the y-axis, sorry, and I'm going to put a dot where 1 meets 1,600. So at that point, it would obviously be far more accurate to do this with a ruler. Go up from 1 and then across 1,600 where they meet, we put our little dot. 2 winners, 800,000. So where 2 meets 800, we put a dot. It's very nice when you've got the graph paper, which is given to you in an exam, you can easily plot your points. When x, which are our number of winners, which is our number of winners, when x was 4, we got 400,000. So where 4 meets 400, we put a dot. And at the point 8, we had 200. And at the point 10, 160. So it's somewhere between 0 and 200, closer to 200 than to 0. So we'll say it's somewhere there. All right, so that's our graph. They've just asked us to sketch that graph, and all we've done here is just plotted the points, and we have this clear relationship where we see as the number of winners increase, the amount decreases. So you can see that as you go up and up and up on the x-axis, your y values get smaller and smaller and smaller. So that is your inversely proportional graph. It doesn't make sense here to join the dots because we are dealing with the number of winners and we can't get 2.5 winners. Doesn't make any sense. There's no way that can happen, so we cannot join those dots up, but we can still clearly see an inversely proportional relationship. So C asks us to describe the graph that we've just sketched. Well, we've just sketched a graph that's curved, definitely a curved graph. All right. If you want to be really technical and get a lot of marks, or not a lot of marks, if it's worth 1 mark, you will only get 1 mark. But if you want to be quite technical and describe it properly, we can say it's a hyperbola. Hyperbola with the P there. All right. Or you can say it is a graph describing an inversely proportional relationship. And you can say, so it's an inversely proportional relationship, it's a hyperbola, or it's a curved graph. And you can also say the data is actually discrete, so we cannot join the dots. Okay, and for all of that, for mentioning all of that information, you will get all of the marks for that part of the question. So guys, example 6 is a really nice example because it tests all of the knowledge that you have gained thus far on graphs. Let's look at example 6. You are asked to choose one of the words in brackets to complete each sentence that they give to you. Okay, so let's go through it. They say, the graph of a directly proportional relationship is in the shape of, and then your 2 options are curve or straight line. Now, obviously, before you answer this, you have to decide, well, what is a directly proportional relationship? A directly proportional relationship is one where, if we work in terms of variables x and y, if x increases, then this would imply we have a corresponding increase in y. So a directly proportional relationship is one where x increases, and that would imply that y increases at the same time. So therefore, that type of relationship would be depicted by a straight line. All right, so a straight line will represent a directly proportional relationship where one variable increases, another one increases at the same time. You can also think of it, if we're looking in terms of the standard form of your straight line, y is equal to mx plus c, your gradient would be positive. All right, the next question. The graph of an inversely proportional relationship, that's the one we've just covered. Remember, that means when x increases, then y would decrease. That's an inversely proportional relationship. That will be in the shape of a curve. We've just done that one. That will always be depicted by a hyperbola. And remember also with inversely proportional relationships, well, in fact, it's in the next question, so we won't talk about that now. The graph of a, and they give you the options here, directly proportional, inversely proportional, or linear relationship always passes through the origin. Now the origin, if I draw you a set of axes or a Cartesian plane, your origin is the point 0, 0, right in the center. So what they're saying is which one of these graphs, the directly proportional, inversely proportional, or linear relationship, will always pass through the origin? And your answer would be a directly proportional graph. Okay, because as one increases, the other one increases at exactly the same time, so they both have to start from the same value of 0. Okay, so that will always go through 0, 0, or as we call it, the origin. 6.4, the graph of, once again, you've got the same options, directly proportional, inversely proportional, or linear relationship, will never pass through the origin. Now be careful here, you need to always read your questions carefully, and this is just a clear example. If we look at that question, it's exactly the same, but there they say always passes, and then here, so that was our directly proportional relationship where it always passes through the origin. Here it says never passes through the origin. Okay, so if you weren't careful and you read over it quickly, you would say, oh, it's exactly the same question, put down the same answer. No. Here, they say never passes through the origin. That will be a graph, as I've shown you in the previous lesson we've just done on inversely proportional graphs. They never pass through the origin. So it would be the graph of a inversely proportional relationship. Inversely proportional relationships will never go through that point 0, 0. Finally, when you plot the points of continuous or discrete data, you join the dots. So let's just remember what discrete data describes. Your discrete data here, we're talking about a certain number of things. So number of people, number of chairs, number of tables, whatever the case is. So it's a certain number of things. Those have to have specific values. Continuous data, things like temperature, height, weight, and so on. You can always get in between values. Okay, so that will be all your continuous data. So when you plot the points of which one of these do you join the dots? You will always join the dots to show intermediate values, which means we are talking about continuous data that we are allowed to join the dots. All right, so that was just a nice little quick revision of all the concepts that you have learned thus far on drawing graphs. Now this is the last example we will look at, last example 7, which is based once again on drawing a graph. We are told that a ball is thrown up into the air and the height of the ball above the ground in meters, so important, they have given you units, so you need to stick to that, after x seconds is given by y is equal to minus x squared plus 4x plus 2,25. Now although it's not necessary for you to know this, this is called a parabola. Depending on the question, you might not need to work with that fact. And in fact, we're dealing with a negative parabola, so it will be a graph that has a sad face. So it would be a graph that has a maximum value at some point. This, in fact, is typical of any type of distance and time type of graphs where you have a ball being thrown into the air. So it's very typical when you're dealing with a ball thrown into the air type question. All right, so the first part asks us to complete the table, and they give us a table with time in seconds and height in meters. All right, so let's complete the table. We have our formula. I don't have to write it down again. We've got y is equal to minus x squared plus 4x plus 2,25. So this is a typical putting into the formula and then drawing your graph type question. They've given you a time in seconds. You have to work out your height. So in our equation that they gave to us, our height will be represented by y, which is the height of the ball in meters. And they told us it's after x seconds, so the x obviously stands for our seconds. Okay, so this would be the value of x, our time, because they've actually told us so in the question, and height would be y. All right, so to find the first value in the table, all we're going to have to do, this is a formula type question, so all I'm going to do is replace the value of x with the value that I am putting in. So with this table of value, I'm going to put in the naught, then put in 0.5, then put in 1, and so on, and then see what all the different y values or all the different heights will be at different points in time. So we put the naught in, so it's minus naught squared plus 4 times naught plus 2,25. If you work all of this out, the first part of this is just going to give me naught. So my answer will be 2,25. So what are we saying? At 0 seconds, so immediately before anything's happened, the height above the ground is 2,25 meters. So that's what we put into the table. If we want to find out what happens at half a second, once again we put the 0,5 in place of the x. And you can really just work this and the rest of these out in your calculator and see that you get a value of 4. All right, I have already worked out these values and we'll just fill them in, but make sure you get the same answers. If I put 0,5 in, I will get 4. Put 1 in after 1 second, your height is 5,25. After 1.5 seconds, 6 meters. After 2 seconds, 6,25 meters. After 2.5 seconds, it's 6 meters. Now, if you just look at the table and what's happening, we went 6,25, and then it seems to be coming back down again. So let's see if this is in fact what happens. At 3 seconds, we get 5,25. At 3.5, we get 4 meters. And then at 4 seconds, we get 2,25 meters. And then finally, at 4.5 seconds, we get 0 meters. So it's come back. It's gone, fallen to the ground. So look at what happened. In fact, it reached a maximum value or maximum heights of 6,25. And thereafter, it started dipping down again. So typical of this type of situation where you throw a ball into the air, the ball goes up, 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 reaches some maximum point, and then it's obviously got to come back to the ground again. All right, so that maximum point here, we've already seen is 6,25, which it reaches after 2 seconds. But that's not what they've asked us. So far, they just say, well, complete the table and plot the points and join the dots to form a smooth curve. Okay, remember, whenever we've got to plot points or draw a graph, easy marks, label your axes. So on my x-axis, my time is the independent variable, so time, and this is in seconds, that I plot on the x-axis. And then on the y-axis, we have height, and this is in fact in meters. All right, so we've got height on the y-axis, time in seconds on the x-axis, and we can call this a very nice word, trajectory. Trajectory is the same as path. So the path or the trajectory of the ball. Trajectory or the path of this ball. Okay, so we've headed our graph, we've labeled the axes, and that means that we've already got marks before we've even put a dot onto this graph paper. All right, now we can plot our points from the table. When x is 0, y is 2,25. So all I do, 0 for time and 2,25. So this is just a standard axis. You're going up by 1 unit each time. So all I'm going to do, when x is 0, y is 2,25. So between 2 and 3 there's 1 unit, so this would be about 2.5. So 2,25 will be slightly below halfway. Alright, so that's where it starts. And then we went up to 0,5 seconds, and there we had a value of 4. So at 0,5, so that's between 0 and 1, we're going to plot 4. And then at 1, we've got 5,25, which is slightly above 5 there. Slightly above 5 and below 5.5. And at 2 seconds, 6,25, which was the maximum point. So I'm just skipping the 1.5, but I will put that in now. So at 2 seconds, I know that it reached a maximum value of 6,25. That was the maximum height of the graph. So I've just put in a key point there to show me the basic shape of this graph is going to go up. It's a parabola, so it's going to go up and then it's going to have to come down. And we know that at 4.5 seconds, it does in fact go and hit the ground there. Okay, so that's going to be the basic shape. Let's fill in the rest of the points. At 1.5, we had a value of 6. At 2.5, so it's coming back to the ground now. At 2.5, there was also a value of 6, so this is the return path. At 3, we had a value of 5,25. So as you can see, these are symmetrical points. All right, this pattern is reflective. As whatever in science they say the time taken to go up is equal to the time taken to go down. That's exactly what's being reflected here. And at 4 seconds, we've got a height of 2,25. So at 4 seconds, we've got 2,25. And then remember, they did say that we can join the dots, but also we know that we can join the dots because this is continuous. Time is continuous. Okay, so now we can join the dots to form our parabolic shape. So we do it as carefully as we possibly can. Right, and then we've got this graph going down till it reaches north, and we can obviously just neaten those points up. All right, and that's the basic shape that this ball, or the basic path that this ball is going to take. All right, so for the C part, they want to know from what height was the ball thrown. Now, very often when you do draw these type of graphs, you will be asked questions on them, so you need to understand what your graph is saying. From what height was the ball thrown, so how far off the ground? And you can see clearly that this ball didn't start at 0, where the distance was on the ground. So this little first part of the graph in height shows us that the graph was actually 2,25 meters above the ground at 0 seconds. So immediately before anything happens, the distance is 2,25 meters above the ground. So that's not a distance the ball travels, that's just from what height the ball was in fact thrown. And then the last part of this question, after how many seconds does the ball hit the ground? So they want to know after how many seconds. That means they are directing us to work with the x-axis because that's the one that represents the time. And they want to know when it hits the ground. So in other words, by the time it gets to a distance, or the distance or the height is 0. All right, so when the height is 0, that means it's back on the ground and it's traveled this entire distance, okay, and made it back onto the ground. How long does it take from start to finish? And that is in fact 4.5 seconds, which we can read off straight from our graph. So that was 4.5 seconds for this entire path that this ball took. Guys, so that's it for the drawing graphs section. I hope that you managed to answer all of the questions as I was going through them with you. And good luck with the rest of drawing graphs.